In this video, we will use SERIESSUM and LINEST in the generation of the Maclaurin series expansion of sine value, and we'll regress it to the sixth degree of polynomial regression. So we begin with the generation of the dataset, which is array formula of sine of the x values. Then we chart this and show the trend line that fits all points of the dataset. And this will be polynomial, and we'll look for one with the highest degree. So we raise the degree to 3, regress to 4, still not good. Try 6. Well, all the points are in the line, so and our r squared is perfect 1. So this is our regression. The polynomial regression will be to the 6th degree. Then we will insert the trend line for the expansion. The expansion, we have it is in the formula series sum of x values raised to the power, the starting power is 1 because 2 times 0, the values of n will be from 0 to infinity. So raised to the power 2 times 0 raised x to the power 2n plus 1. 2 times 0 is 0, 1. So our starting power for x is 1. And the next will be 2 times 1 plus 1. So 2 plus 1 is 3. So, and then 2, 4. So 1, 3, and 5. So it is incremented by 2. So we now solve for the coefficients. So we begin with the numerator, array formula, minus 1 to the power n. So that's the numerator. Now the denominator. So it is divided by factorial 2 times n plus 1. And we will enclose this in the parentheses as part of the array formula. Now that we have the coefficient, we can now use the series sum. So array formula, series sum of the x values. Now it's raised starting from 0, from 1, and incremented by 2, and the coefficient will be this range. So our values of x are, the expansion is the best approximation of our function sine. So they're almost the same. We can show that in the chart. So we enter this in the chart, edit chart, the series. We'll add the expansion, the Maclaurin series expansion of sine. And we'll also show the polynomial equation, the same level, the same degree. So the blue ones are now covered because they're the same. And we'll show the equation. So you will notice the regression coefficients are the same. 0 for B0, 0.955 for B1, 0 for B2, 0.14 type 0.14 for B3, 0 for B4, 4.25 times 10 to the minus 3 for B5, and 0 for B6. And we can show that in our LINEST. So we will drag this downward and make comparison with our LINEST function. So to get the LINEST, we enter the 1 comma x matrix. So we start with the power. So our transpose of the x values until 6, because we're using 6 here, the level of 6. So we complete the 1 comma x matrix, which is array formula of the x values raised to the power, for this case, 0. So that's the 1 column. Then we lock the references. And we'll show the x column. This column matches to our x values. Then the x squared column. Then the x cubed column. Then the x to the fourth column, x to the fifth column, and x to the sixth column. Now we can use the LINEST. LINEST. This time we'll start with the function itself, sine x and data x. So our B0 match to our trend line. B1, 0.9554 is 0.955. B2 is 0, the same. Our B3 is negative 0.13952, rounded up as negative 0.14. Our B4 is 0. Our B5 is 4.25 times 10 to the minus 3. It's the same. Our B6 is 0. Next, we enter the LINEST for the Maclaurin series expansion. LINEST of these, the y values and the x column. Our B0 is 0. 0.955, they're the same. It's also the same. It's rounded up as negative 0.14 and 0. Then 4.25 times 10 to the minus 3 and 0. So we've just shown the use of SERIESSUM and LINEST in the Maclaurin series expansion of SINE and its polynomial